Alright, so today we're going to talk about writing proofs involving angle relationships. So we have our angle addition postulate, so this is very similar to our segment addition postulates. This allows us to add two smaller angles together to equate a larger angle. Saying by, we have our angle ABD, this smaller angle right here, plus angle DBC, this angle right here, have to add to be the entire angle ABC. Now, in addition to that, there are important postulates, are linear pair postulates. This states if two angles form a linear pair, then their measures will add to be 180 degrees. So we'll recognize our linear pair looks something like along these lines. Angles 1 and 2 must add to be 180 degrees. That's what the linear pair postulate is saying. Now the two very similar theorems, we're going to prove both of them, are congruent supplements theorem. This says angles supplementary to the same or congruent angles are also congruent. And then congruent complements theorem, exact same concept, but now we're talking about complementary angles instead of supplementary. Please remember supplementary angles add to 180, whereas complementary are angles add to 90 degrees. So we're going to prove both those theorems in this video. We're also going to prove the vertical angles theorem. This states if two angles are vertical angles, then they are congruent. We've used this concept in a previous section, but now we're going to prove why it actually is true. Where does that come from? Some other useful theorems, we're not going to prove either one of these two, but we can use them in the future. We have our right angle congruence theorem. This is all right angles are congruent. And our perpendicular congruence theorem, which is perpendicular lines form congruent adjacent angles. So our first proof, we're going to prove the congruent supplements theorem. Okay, so we have our diagram. So they're purposely not being joined together. I don't want you to assume they have to always be connected. They're just angles floating around. Where angle 1 and 2 are given to be supplementary angles. And then 2 and 3 are also given to be supplementary angles. We want to use that to prove that angle 1 and 3 must be the exact same. They are congruent. So we'll write this with a two-column proof. So we'll start with our given statements. Angle 1 and 2 are subangles. Angle 2 and 3 are also subangles. Now, if angle 1 and 2 are supplementary angles, well, that means they have to add to 180. So angle 1 plus angle 2 equals 180. The same is also then true for angle 2 and 3. 2 plus 3 is equal to 180. The reason why? These are definitions of supplementary angles. We're told they're supplementary in the given statement. What does that tell us? They have to add to be 180 degrees. Well, if both angle pairs have to add to 180, that means they must equal each other, because they both equal 180. So angle 1 plus angle 2 would equal angle 2 plus angle 3. This is our substitution property. We are replacing 180 right here with angle 2 and 3, because angle 2 and 3 also equals 180. We notice in this equation, angle 2's will cancel out, and they will subtract out, leaving just angle 1 congruent to angle 3. And that's our subtraction property. And that's your first angle proof, our congruent supplements theorem. Okay, again, very similar logic to what we saw in the segment proofs, so make sure you understand the material there. We're going to do something very similar now with our congruent complements theorem. So we have our complementary angles, angle 4, angle 5, angle 6, so we are given angle 4 and 5 are complementary angles, and angle 5 and 6 are also complementary angles. We're going to use it to prove that the angles are not exactly the same. 4 and 6 would have to be the exact same measurements. Again, two-column proof. First step, we'll start off with our given statements. angle 4 and 5 are comp angles. Angle 5 and 6, also comp angles. That's given. Well, this is pretty much going to be the exact same setup as our congruent supplements theorem. The one key difference is we're talking about complementary angles instead of supplementary angles. Since we're talking about complementary angles, this means that the angles must add to be 90. So angle 4 plus angle 5 equals 90. Angle 5 plus angle 6 equals 90. And that's our definition of complementary angles. Well, if they both equal 90 degrees, they have to equal each other. So angle 4 plus angle 5 equals angle 5 plus angle 6. That's our substitution property. And since angle 5s are on both left and right-hand sides of the equation, they will subtract out, leaving just angle 4 congruent to angle 6. That's our subtraction property. And there's your second angle proof. Again, pretty much the exact same proof as the congruent supplements theorem. We're just talking about complementary angles instead of supplementary angles. Okay. The other theorem we wanted to prove is our vertical angles theorem. So vertical angles. 1, 2, 3, and 4. We are given this diagram. That's all we're given. We want to prove that angle 1 and 3 are congruent. We don't need to show that both 1 and 3 and 2 and 4 are the same. It's enough to show that one pair of vertical angles is congruent. That means all other pairs of vertical angles will also be true. So our first statement is our diagram. That's our given statements. Diagram, not diagram, whatever that was. Well, based off the diagram, I know 1 and 2 are both a linear pair. So angle 1 plus angle 2 equals 180. I also know 2 and 3 are another linear pair. So 2 and 3 also add to 180. That was my linear pair postulate. Well, since both pairs of angles add to 180, they must equal each other. So 1 plus angle 2 equals angle 2 plus angle 3. That's, again, our substitution property. And since angle 2s are on both left and right-hand sides, they will subtract out, leaving just what we want. Angle 1 and 3 are vertical angles to be congruent. And there's our vertical angles theorem proof. Not too complicated, don't need to deal too much more besides that. Alright, so let's talk about one more proof, one more angle proof. This one is not a theorem, so we can use any one of our theorem concepts to prove this. So we have our line right here, another line intersecting that, and a line that comes off of it. So we have point A, B, C, D, E, and F. I'll also label these as angle 1, 2, and 3. So we are given that BD, let's call these guys arrows, BD bisects angle ADC. I want to use that to prove that angles 2 and 3 are both the exact same measurements. They are congruent. So that's our given statement. BD bisects angle ADC. That is given to us. Well, if BD is an angle bisector, as we saw before, that means it's going to split into two equal angles. Well, BD bisects angle ADC, that means angle 1 and 2 are my two congruent angles. So that's my definition of an angle bisector. Now, I need to say 2 and 3 are the same. So if I can say 1 and 3 are the same, I can then just substitute in angle 1 for angle 2 and be done with the proof. If we look at angles 1 and 3, those are both my vertical angles, so therefore they're congruent. And now that I have angle 1 equal to both 2 and equal to angle 3, that must mean angle 2 and 3 are also congruent by, again, our substitution property. And there's our fourth angle proof. There are so many more proofs we could use using these different angle theorems. There's really almost like an infinite number of proofs. We'll get into more complex proofs once we start talking about more complex issues using parallel lines in the next chapter. Start talking about triangle proofs in the following chapter, and then so on from there. So be sure to ask questions, and I will see you next time.